Hello everyone, welcome back to Math Specs. Today we're going to learn how to combine like terms. So let's get started. First, we're going to begin with the definition. Like terms are terms that are alike. They have the same variable, which means that they have the same letter, and they also have this letter, this variable is raised to the same power. So here I'm going to write squared, squared. But they may have different coefficients, and coefficients just means numbers in front. So the numbers. And here, for example, I could have 6 and 4. And these two would be considered like terms. Or if I had 1/2 b and -2b, these also would be like terms. I like to think of this in terms of twins. So here we have twins on the left and twins on the right. And these would be our like terms. So I would have something like B and B. And maybe in the front, see this one is wearing a blue shirt. This one's wearing a green shirt. So these colors of the shirt stand for the numbers or the coefficients. So maybe this one will be 4. This one could be maybe 1/2. Right, so they're still twins, they're still like terms because they have a b, they have the same variable, but even though they have different numbers in the front, just like these twins are still twins, even if they wear different clothing or different color clothing. Okay, so let's go over here. Maybe here we have x squared. And the numbers in the front are different, our coefficients. This one could be maybe -5, and this one could be 4. So these are like terms because we have the same variable. We have x squared and it's raised to 2 to the second power. And here we have an x and it's also raised to the second power. And they have different coefficients. This one has a -5 and this one has a 4, but they are still like terms. Okay, so let's continue. So here we're asked to identify the like terms in the expression. I'm going to use different colors for this. Here we have x squared minus 5 minus 8x squared plus 5x minus 6 plus 3x. So what I'm going to do is start here on the left, and I have an x squared. So I want to find something else that has an x and a squared at the top. So here I have minus 5 minus 8x squared. Here's another one, so I write it right here. Then I go down again, plus 5x minus 6 plus 3x. Nope, that's about it. So I'm going to go on to the next thing. And minus 5. So here I have no variable. It's just a constant. It's just a number. So I go down and I have 5x, but that has a variable. So that's not a like. It's not a like term. And here I have minus 6. And it's also just a constant. It's just a number, has no variable. So those two would be like terms. Now for positive 5x, here I have a 5 and an x raised to the 1 power. So I want something that kind of looks like this. And here we have plus 3x. So these two would be like terms. And now I can simplify. So I have x squared. Remember, we have a 1 here. 1x squared minus 8x squared. That would give me minus 7x squared. And minus 5 minus 11 will give me minus 5 minus 6 will give me minus 11. And positive 5x plus 3x is going to give me 8x. It's positive 8x. So you see from this up here, from all of this that we did, this expression, we've now simplified it to this. So we've made it look a little bit more cleaner than what we had to begin with. And that's why combining like terms is useful to us, because it helps us clean up or simplify our expressions. So let's continue. So we're going to be cleaning things up. By combining like terms, we are cleaning up we're simplifying our expression. And we can use the distributive property to help us do this. So think of it as you sorting laundry, and we're combining our like clothing. That is what we're doing with when we're combining like terms. We're putting things that look the same together. So let's go ahead and continue. So say that you had to sort these clothing all at the top, they're all red or different hues of red. And these would be our like terms. So we maybe could have b squared, b squared, b squared. And the only difference would be that they have a different number in the front, a different coefficient. So they are all like terms. They're all similar. And here we have these like terms on the bottom. For the bottom, here we have all of these blue articles of clothing. And for our analogy of like terms, maybe we could have y squared. And the numbers in the front could be different. But these would be like terms at the bottom. Why? Because y squared, and here it has a y squared too. This also has a y squared, and it doesn't matter that they have different numbers. Just like when you wash it in the laundry, it doesn't matter that this is a skirt and this is a shirt, or that this could be a jacket. Since they're all the same color, you would wash them together. Okay, so let's continue to the next slide. So here we're asked to simplify this expression. So what we're going to do is use our distributive property. So we have 2 times x plus a plus 3 times 6 minus x. So I'm going to distribute the 2 into here. So I would have 2x plus 16. Then I would distribute the positive 3 here and there. So I would have positive 18 minus 3x. And now I combine my like terms. So I have 2x here, and I have a minus 3x here. So I would write those two next to each other. Then I have a positive 16 and a positive 18. So I would write those two together. And now I simplify. So I have 2x minus 3x. This is going to give me minus x, or minus 1x. And I have positive 16 plus positive 18, and this will give me a positive 34. So now you see how we've been able to take this expression at the top with all of these grouping symbols or parentheses, and we've been able to rewrite it or simplify it down here by using the distributive property and then by combining like terms. So here we combine like terms. And up here, we used the distributive property. Okay. Well, congratulations. Today you learned how to combine like terms. Thank you for your time and attention today. Good luck, and we'll see each other in the next video.